Okay, in this presentation we're going to have a quick look at the Poisson distribution. So suppose that electrical power failures occur according to a Poisson distribution with an average of 2 outages per every 20 weeks. Now, so that is our Poisson mean, and this will give us like the information that we need to proceed this piece of information here. We're also told explicitly it's a Poisson distribution because some cases that might not be the case. So it's just one question in this particular instance. Calculate the probability that there will not be more than one power outage during a particular week. Now you notice here the question asks us for a particular week. Okay, so the way this is set up, we actually have it in terms of m here. Okay, that's the Poisson mean m, but typically it would come up quite often as lambda as well in other situations, but notation is not consistent, so this time I'm going to use m deliberately to be different, okay, with regard to notation. Okay, so anyway, this is a key piece of information here. The average number of failures per week is m for 1 week is 2 divided by 20. So if there's 2 in 20 weeks, that means on average there should be 0.10 failures per week. Now, it's okay that that is a real number, like a fraction, 0.10, 1/10, when we are talking about an average, okay? So obviously it won't happen that you get 0.10 occurring, but on average you could get that over 10 weeks, that you have 1 over 10 weeks, which would correspond to 0.1 for a particular week. Now, not more than one power outage per week. So essentially what we need to do there is calculate 0 outages and 1 outage. And what we're going to do is get the complement of those. Okay, so we're going to calculate those two probabilities. That is the no more than one, and okay. So this is the key piece of information. This is the probability mass function for the Poisson distribution. Probability of x equal k, where k is the value we're interested in. M here is the Poisson mean, so e to the minus m times m to the power of k divided by k factorial. Okay, and just as a remark, that may turn up as lambda in your books or in your notes or something like that. Lambda is more common, but m does pop up a lot as well, so that's why I'm using m in this particular instance. Okay, so probability of x equals 0, that is e to the minus m, that's e to the minus 0.10, times, in this case, k is equal to 0. So m to the power of k is 0.10 to the power of 0. That's necessarily 1. K factorial is 0 factorial. That's also 1. So what we end up with is e to the minus 0.10, and that is 0.9048. Calculate the probability of x equal to 1. So again, we have e to the minus m is e to the minus 0.10. M to the power of k is 0.10 to the power of 1, which is 0.10. K factorial, where k is 1, k factorial is also 1 factorial. So what we end up with is e to the minus 1.01 times 0.1, and we'll round that up to 0.0905. So the probability of x less than or equal to 1 is just adding those two together, okay? 0.9048 and 0.0905, that works out to be 0.995, and 0.995 is the answer that we are looking for. That is the probability of no more than one power outage in a particular week. So we leave it there.